Good day to all fellow speakers and delegates to this highly anticipated Offshore Site Investigation Conference organized by the Geological Society of Malaysia and Offshore Professionals in Deram Bahad. I would like to thank Tuan Abdul Rashid Jafar and Dr. Auzani Bashir for inviting me to speak on behalf of the geoscience community. I'm indeed thrilled and happy to be given this opportunity, and I hope I can learn and also share my experiences for a lot of you out there, because they are well esteemed speakers during the course of the rest of today and tomorrow. So there's a lot of content there for us to learn and develop together as from a geoscience community. Now, as introduced by the organizers, I've been part of this industry for the last 20 years. I'm a trained geotechnical engineer and a project manager during my formative years. Currently, my focus is on the business aspects in Fieldgrow, more forward-looking business development, but definitely a highlight or probably a point of my my role is to actually focus on bringing innovation and technology advancements in the kind of work that we kind of do. I mean, whether it's geotechnical or general marine site characterization activities. So my current passion is to build on this, and as you know, the specific needs are not only driven by the search for more energy resources, but also to counter current and future challenges brought about by climatic change, so that we can be part of the global drive to create a safe and livable world. So my main message in this keynote presentation is just to give you that broad perspective from my lens and create a high level awareness on about the current and future outlook about the marine site characterization, or in short MSC, industry, and how innovation plays a big part in creating value. My keynote speech comprises of these 6 sections. I will give an initial overview of the current global energy climate and key industry challenges. I will then proceed to give you some specific high insights on why I think the AAA approach for any developments in the MSC lifecycle is key in reducing risk and cost and maximize value creation. I will explain what AAA means also in this particular section. Then I would like to get into the innovation advancements, which is specifically related to workflows and acquisition methods. There will be a couple of deep dives into specific technological solutions that have been recently pioneered in the industry. And to conclude, I will provide my perspective of what the future beholds and hopefully be able to create optimism for the future. Now, to set a bit of context to my keynote, what I would like to highlight here to the audience is the big shift that happened from 2014 onwards, where we all know with the oil prices falling, there's a big shift in the dynamics within the industry. The volatility in this area led to a huge industry effort to reduce costs and optimize operations to stay profitable. Now, the last year as well, the pandemic that happened in 2020 created another mode of disruption in the whole process. However, the most important point here is, since 2014, there have been a lot of businesses evolving and innovating in the process to make sure that they can actually get to the stage where their businesses can be run leaner and faster. So clearly the phrase necessity is the mother of all invention is apt here, because we are in that phase now, and because after probably 6 to 7 years of a lot of research and development and innovation happening, we are probably in a position to look much more positively towards the future. Now, there have been focuses on many areas, but I think on top of my head, the areas that we have a bit of we probably are ahead of the game here is, one is digitalization to maximize value capture. Number 2 is enhanced geohazard management in the MSC industry. That is important. The agility in deployment of assets, quicker, faster turnarounds, lighter assets, autonomous and remote operations. People can't be traveling, so we need a lot less people on the vessel, but still be in a position to manage the operations. And finally, but not lastly, what I would think is a reduction in the carbon footprint in order to be in aligned with the Sustainable Development Goals, which is prescribed to all globally across all the countries. So this section, I just want to give you an overview of challenges in the region. Most of this you already know about, but it kind of actually also sets a bit of context why how we can actually reduce the risk profile for operators and developers. So the present slide shows a familiar side of a very old jackup rig incident. We all know that these incidences are not one of the past, it still happens. Now, the recent event last year, which was probably available in the public domain, was a rig incident happened in Indonesia, where it actually struck a offshore platform and created a fire. The litigation process is happening between both parties, the rig owner plus the consortium partners, and there's millions of dollars being held as they're being held liable for it. Now, so pinch-through situations continue to occur. Now, in this region, the Sunda Shelf or the geology of it has created a lot of risk, additional risk for jackup emplacement operations. But again, what we said, it keeps happening on and off periodically. Then the next hazard that or challenge that I would like to talk about is shallow gas. Now, this is a photo from the Actinia semi-sub shallow gas blowout event in Vietnam, close to 30 years ago. Again, a very old picture, but what it actually shows you is a crater of probably 2 kilometers wide, a blowout that went up all the way about 40 meters above the sea surface, and eventually what happened is the rig rolled over and settled with a 15-degree list. Now, we all know widely that there continue to be such incidences. Yeah. So for us, two important concerns is first to understand why this type of incidences happen time on time, and secondly, how such punch-through and shallow gas blowout risk can be further mitigated and reduced. So probably this is a good time to reflect on such issues. For that, I would like to allow the audience to think about two key questions here. One, are such type of incidences contributed by the multiple interfaces in the MSC supply chain activities that raises risk? What I mean here is having independent parties involved during the life cycle. It could be an independent supplier for geoconsultancy, an independent supplier for the geotechnics, for the geophysics. Do you all think that there's probably things that could have been missed in translation? That's number one question. Yeah. Number two to think about is, considering this in mind, would technological advancements in data acquisition, for example, data processing speeds, predictive analytics, make a difference in providing more insights and help us become more prepared for the situations? I'm sure that many of you here would have excellent views and thoughts about this. Please hold on to those thoughts. I think we have a Q&A session after this. But let me assure you that I'll be going through it as well during this presentation to try and actually resolve or solve these questions with the topic of innovation and the technological advancements. This is a topic, again, just to highlight that incidences does not happen in matured industries like the oil and gas. It also happens in the new frontier industries like the offshore wind farm in this particular region. Now, in this particular event, a heavy lift vessel experienced a pile run incident. Now, the pile hammer got detached and fell on top of the pile. I mean, the good thing that came out of it is there was no injuries and not much damage happened to the pile or to the barge. Now, the root causes are still being investigated. However, it raises the most important point here, that how do we tackle risk in new frontier areas? Do we really need to redouble MSC efforts, especially in these areas? Yeah, this is something also to think about. This is also a very old example of an incident that happened in the northwest shelf of Western Australia. The methodologies for the pile design was based on Gulf of Mexico and North Sea. type of design methodologies. So during the installation, there was a pile run from 0 to 60 meters and then from 70 meters onwards for 30 meters. So that led to a complete awareness in the industry that, look here, we need to treat carbonate salts differently compared to silica salts. Yeah, and the importance of actually understanding more and about the skin friction, what is mobilized and what is not. So the remediation work that happened after that was extensive. It was 6 years and it was worth $340 million. Now, what is the learnings that comes out of this? The learnings that come out of this, all this is the different regions have different soil characteristics. Yeah. However, we need to adequately investigate new areas and be able to design methodologies based on information from other areas. However, using local and regional site-specific information. It might not be necessarily in that particular area, but to combine information from other areas in the on the Northwest Shelf as well, to actually provide more insights and probably for the risk to be known ahead of time rather than later. Now we take a quick peek into challenges that is common in the deep water regions. This graphical overview sums it up by showing most of the challenges that could be faced for any developments. Now, in this Southeast Asia region, we could say that probably stope stability issues on escarpments or and resulting debris and turbidity flows are probably a risk. Now, I will run through one of the examples in the subsequent slide. Gas hydrates as a risk to installations due to dissociation issues based on temperature differentials. There's also active mud volcanoes, shallow gas and shallow mud flow issues, and seismicity because it creates issues for liquefaction potential. So the key challenge here is to transform known unknown to a known state. In what it means is, it's better to understand the risk that's ahead of us for the risk owner so that they can actually work with the consultants and the contractors to make sure that those risks are mitigated via engineering remedies. One typical deep water geohazard I mentioned earlier was the debris flow. Yeah, it can pose significant risks to subsea infrastructure. It is inherently very difficult to analyze, and hence the importance of reducing uncertainty in debris flow modeling. This can be done via a combination of actual site-specific qualitative and quantitative geodata, along with the geoconsulting expertise. The message here is to highlight that transforming the known unknowns to the known is critical, as I mentioned to you earlier in terms of geohazards, as otherwise the consequences can be huge and will most likely result in millions or dollars of remediation works and delays in the huge CapEx project. Now, this is coming to the next section now. What is AAA and how would it benefit the whole process? Now, so AAA stands for Acquisition, Analyze, and Advise. The application of AAA service offerings throughout the life cycle actually is important because it is a form of it's an iterative process to validate data during various stages during the life cycle. So that's why it's very critical to actually look at the 3 A's in a manner that it is helping each stage or each milestone. It could be after geophysics, it could be after geotechnical. The iterative process continues to refine the risk profile. So that brings me into the picture, the graphic here, in terms of showing the cone of uncertainty. Now, which we, as a lot of us as project managers, use to actually understand and put a bit of logic behind how the reduction of risk happens via various milestones. Yeah, so it is one of the key pillars in this concept on identifying and mitigating by a form of an iterative process. So before I get into details in this section, I would like to draw your attention to this statement from S&P Global Report. which exemplifies the importance of looking at every interface of a large capex project and assessing the risk associated with it. Now, one thing that you probably want to take out of this is the point that it states that the interface management in the project life cycle for any development project is key critical to the success. Yeah, and for that, I think it's most important for the remit of this presentation is to understand that geological complexities, knowing it upfront is mission critical. The essence of this slide is to highlight how typically marine site characterization services have been viewed in the industry. Now, there's always a splitting of work into different work packages. That means whether it's meta-ocean, geophysics, geotechnical, it's actually split into different packages and to different contractors. Now, the point to ask ourselves is, does a lot of these interfaces create complexities and raise the risk profile? So the impacts could be a lot. I mean, in the sense of breaking it up, it could be procurement time and cost. It could be a lack of project integration. Because the opportunity for optimization is probably, I wouldn't say missing, but probably it's affected, and that can create cost overruns. And the lack of data integration, for example, can impact on time and effectiveness of critical decisions. Most importantly, what is the residual risk that's remaining on the table after completing the whole process and prior to the EPCI phase? Now, the goal here is how can we reduce complexity and costs from a concept to completion of the offshore development better? Now, the optimistic view here is that with technological innovation and advancements, in the recent years via digitalization of geodata and technologically advanced data acquisition assets that is there in the market now or is coming up in the future, we can accelerate the integration of data and help in capturing value from the whole process and reduce the risk for the risk owner. Now, there are reasons to be optimistic now because there are means to integrate geodata and make those informed decisions early in the life cycle. A few case studies here will be presented in the next section to show some substance to this statement. So based on what I've gone through so far, there are 4 high-level steps that creates value. They are multi-source data integration and mapping. What it means is you get all the information via multiple sources. We can speak to each other via a common technology platform. It doesn't matter. It could be meta-ocean information, seismics, geophysical, geotechnical. It's there. So the idea is to get from the step of unknown, knowing nothing about the site, to a stage of knowing known unknown stage. Second is the data visualization aspect of it. You want quick and user-friendly interfaces to enable the visibility of the information throughout the life cycle. Number 3 is predictive analysis, developing machine learning algorithms to predict outcomes based on extensive qualitative and quantitative data sets. Note, I will be talking about this in the next deep dive, where predictive analysis, there are cases where we use predictive analytics in certain scenarios. Now, last but not least is a scenario analysis, where this component is where the combination of both the consultants and the risk owners getting together and developing such cost versus risk scenarios. And this is based on geodata insights gathered throughout the life cycle to make the most appropriate investment decision for the subsequent development activities. Now, before I get into the innovation phase that comes shortly and highlight the digitalization wave, there needs to be that acknowledgement that the AAA approach can be difficult to be carried out because of the fragmentation of information across various interfaces. We talked about the breaking into work packages of a whole large CapEx project. As an example, in the past, there's probably a significant delay in getting field data to the hands of the consultants who perform the desktop study. Yeah, and once the data is in their hands, hands of the consultants, there will be some additional effort and lead time to assimilate the data. All this takes time because it's not in a common platform. So now, as I've been leading into this section of innovation, I would like to provide you some high-level insights on how the industry involved in terms of automation and the use of machine learning algorithms in geodata flow. I mean, the ease at which information is available at the fingertips currently is amazing and revolutionary in some areas. So in short, this section will focus on remote QC and the use of cloud-based systems. Number 2, online processing and delivery. Number 3, automated processing capabilities. And lastly, the automated interpretation capabilities. So as a provider of such service offerings in the industry for the last 60 years, Fugro has been looking at ways to actually add value to end clients and the users of your data. In the last few years, Fugro has been purely focused on innovation and internally spending the most time and effort in creating both exploration and exploitation type of innovative solutions to further develop and enhance our in-house capabilities in both the geodata digitalization space as well as the assets to acquire the data. So within the MSC team, we have set ourselves a goal, to digitalize the whole journey. So as you see from here, there's so many initiatives that's ongoing within our company. I mean, the main drivers for innovators like ourselves, so it's not just Fugro, there's a lot of companies out there that's actually innovating and trying to create a digitalization platform. I think the most important drivers for this are you need to fully digitalize MSC geodata supply chain. So what I mean by this is you need to get into a situation where the geodata can be accessed, processed, analyzed, and delivered from anywhere, from a common platform. Number 2 is to deliver data agnostic solutions where you can work with information from different databases. So basically the goal here is to deliver digital components that solves business needs right away and can be leveraged across multiple data flows. This is a bit of a summary of machine learning, which we are going through in the company, and it's similar to other companies as well. So the industry stakeholders here, I mean, we have accumulated a lot of data. I mean, a lot of us have been in this industry for many, many years. But to unlock the insights, we need to make sure that it is in one common platform. So the advancement in data science and computing power have provided this key to unlock the insights. So machine learning helps us analyze a huge amount of data. So that is the most important thing here. So because of technology advancements, as long as the data is available in a common platform, machine learning will help us look towards predictive analytics. Now, with the previous, I'm proud to say that our team from Fugro won the OSI2021 machine learning competition. The competition was participated by 60 other teams from industry as well as academia, and involves the application of machine learning to predict pile installation driving behavior. So blow count versus depth, for example. So I can share with you that the data sets that were used for the competition did not originate from Fugro, and hence the team did not have any added advantage to start with. Now, what did the winning team come up with? I mean, they combined machine learning techniques with geotechnical expertise to develop a stable and reliable pile driving model, which proved to be superior. Now, feature extraction is a key step in building a machine learning model. And the combination of it, the data science and the geotechnical knowledge, is the secret sauce in the winning recipe. So it also comes in with your experience, your subject matter expertise, and using a lot of that, the brain power that's available in your organization. The point also here that I would like to make is this similar framework and architecture can be applied across any, for any geotechnical applications based on existing data sets. Such machine learning framework will also allow for regional characteristics to be readily captured and hence lead to better predictive models suitable for regional and local soil conditions. So this is merely an overview to show that the digitalized CPT workflow, which I'm going to talk to you shortly, is actually it's an actual product. And this overview highlights the period that the product went through a proof of concept phase until actually being available as a commercial product. So in this particular case, you'll see it's roughly about 2 years, and it is actually out there in the market. So here comes, the first case study of the presentation. I think it's going to be quite interesting to show you the advancements that we have made. So before I go into the solution, let us all meet the team. Yeah. So in this particular case, we have few characters. We have Eva, the geotechnical engineer on board the vessel. We have Brandy, the Fugro operator that's on the vessel. We have Timo, the Fugro geotechnical engineer that's back onshore. And we have Denise, the client technical manager, and we have Adam, the client project manager, who's involved in the whole project, not just for geotechnical operations, but also for geophysical and other relevant work packages within the whole large capex item. So we start at time equals 0. Yeah. So this is when the completion time for the acquisition of the CPT, from sensor to the actual downloading of the information via the app that is available on the vessel. So 10 minutes into the receiving the data, the raw data is synced already to the cloud automatically. Yeah. So that's already available in a common platform. 30 minutes later, the field data is validated in the cloud. Basically, it can be done. Either it's from the shore or from the vessel, it does not really matter. So anyone can validate the data, and that's uploaded and updated on the cloud. So 60 minutes later, what happens is this validated field data is available in the delivery portal. And that delivery portal means basically it's on a file in a client-facing SharePoint site, and also a visualization in a map interface, which the client has access to. So this creates a lot of within 60 minutes, all the data is actually reaching the decision makers back on the beach. And beyond 60 minutes is more of the reprocessing and approval of the final data, and those data is also automatically uploaded and stored in the client portal and in any other local storages. So as you see the data journey now, let's hear what the team members perceive as the benefits of this functionality. So for Dennis, she has fast access to the latest information. She knows what geotechnical data is. She can interpret the information, and it gives her a lot of insights within 60 minutes of actually getting the data from the ground. For Adam, looking at the whole project per se, he can accelerate his development by early design and layout designs, for example. Yeah, and he can also think about reducing people on the vessel. And what does he mean? Reduce HSE risk. For Timo, as a geotechnical engineer from Fugro side, it doesn't matter where he sits. He might sit in the office, he might sit at home. He can still process the data, and it'll be automatically linked to the cloud. So the main takeaway from this slide is you can deliver faster from anywhere. Doesn't matter. As besides faster insights, they can also be delivered with no or less people on the vessel. Again, that is a big benefit. And what I would like to say here is, with all these benefits, this is something that we can deliver on projects today. So basically, it's not bird in the sky, but rather bird in the hand, and is being done across some projects that we do currently. Now, as you've seen from the previous workflow, all geospatial information can be provided via dashboards and interactive map interfaces. Yeah. So irrespective of the solution provider, it could be Fugro, it could be anyone else, what value would that interface create? First, the value is it provides clients with a full overview of project scope and progress and results. So a complete geospatial overview. Yeah. Everything is available in one platform. Second is up-to-date geodata. Quickly, you can process real-time information. You know what's happening on the vessel. Data is available, and if anything needs to be redone, you can make decisions in minutes. Organized and cloud-based delivery, again, is delivered, integrated and delivered based on client specifications. So it is integrated with the client document management system. And last but not least is a reduce uncertainty faster. Yeah. So with fast access to all the information out there, the client, like we talked about the client PM, he can accelerate development by early design and layout decisions. He's getting information as the work is being performed in the field. This slide is more to summarize the hub site we're talking about, where all the information is available. I think what I would like to just reinforce is the statement that I made earlier in the presentation, is that in order to have the best applications of the AAA concept, you need to have a digitalized platform for all services across the MSC geodata supply chain, because that is where the value is created for the end client. A second case study here is a site in the North Sea, which is in total of 350 square kilometers. Now, what we're trying to assess here is what can we use with the qualitative data sets, which includes a lot of geophysical information. Yeah. So conventionally, the data sets are evaluated by geodata consultants via desktop studies. Yeah. And it's probably confined to the information that's there. Now, what we are trying to highlight here is, if we use machine learning algorithms, what can it help us do more? Is there more insights that can be unlocked with the data that's already in hand? So what is the answer? The answer is yes, it can be, because it is by leveraging an application of machine learning to the field of geoscience. So the additional output, what you see on the screen here, is an astonishing 1.5 million synthetic CPT profiles being generated for an actual project from the qualitative data that I showed you earlier. So what we need to understand here is there's a lot of things that can be done. So here you see the actual CPT profiles that's being actually superimposed onto the actual CPT results that or the synthetic CPT results that were actually delivered from the machine learning module. So these figures show the actual results of the prediction of the 5 locations, yeah, with actual CPT data that were excluded from the model training. The solid blank lines show the actual CPT profile, while the solid red lines are the synthetic CPTs generated from the machine learning model. The 90% confidence interval generated from the machine learning model is shown as shadings. I think you can see it from the overview here. In overall, it can be observed that the machine learning model predicts the cone resistance reasonably well for the top 20 meters. Yeah. Below the 20 meters, the trend type prediction is actually used to actually determine the type of profiles. So the key benefits of this the ability to actually come up with synthetic CPTs are, it improves the geotechnical understanding of the site. It provides cone resistance estimates using 2D UHR seismic lines. It also helps identify areas where possibly more geotechnical data is required. And it gives us the power to actually refine existing geological ground models as well. So what does GNV-GL have to say about the comment on the report, for example? They see this as a cutting edge development and a huge step to bridge the gaps that probably is there at the moment. Yeah. So, I mean, the synthetic CPT profiles can be used as a background information to support design basis for future wind turbine solutions. But again, it is applicable. I think this is applicable across the whole industry, even oil and gas. So having covered innovation related to geodata flow, now I would like to move on to discuss key technological innovations on the operational and equipment aspect of data acquisition. Now, this section is more to highlight the innovations that we have in the asset base, or the hardware space. I mean, to name a few, there's a lot of speakers here and a lot of companies that's attending this conference are already there as well, along with Fugo, in terms of actually bringing out new innovations to the market. For example, there's opportunity for remote positioning. There's opportunities for remote inspections. There's opportunities now for remote QA/QC. You don't really need a client rep on board the vessel because the client representative is already seeing the information back in the office. Remote audits, audits and surveys done remotely without physical presence on vessels, for example. Remote operations, the uncrewed survey vessels doing hydrographic surveys and logic ROVs and AUVs, for example. So I'm sure that you'll hear a lot more of this over the course of today and tomorrow. So specifically talking about remote operations, what are the key differentiators here? I mean, the key differentiators here are risk mitigation. Now, we are moving people away from the vessel, having less people on board. That reduces the risk, and having more people actually process the information back to the beach. Now, the program, what we're trying to do is here we have solutions which actually expedite data delivery. So you can actually do multiple campaigns, not multiple campaigns, but multiple work scopes within one bigger campaign to actually with different multiple assets to actually get work done, for example. So if you look at geophysical survey with a parent vessel and a child vessel, you probably like an USV, you can actually do twice the amount of work with the same amount of time. And client cost reductions. So it is proven that there's a return on incremental investment is there based on this kind of solutions that's available. And it's flexible and scalable as well. And last but not least is the sustainability element of it, in terms of doing our bit to actually reduce the carbon footprint and support the sustainability drive to create that safe and livable world that we are looking out for. Now, the upcoming slides mainly, it includes exploitation type of innovation, which means taking the current leading technologies and building them to create additional value. A prime example of this is a seabed CPT system. The feature of this is basically a friction reducer module, which allows and reduces thrust and friction on the rods, which allows for deeper penetrations. Now, the coil rod system, we have it on the older system as well, but there were limitations because you can't penetrate the full extent of what the capabilities are. But with this solution, we actually providing value to the end clients like Shell and RWE, for example, and they can actually complete field work much more quicker, and data being available back in the beach to make decisions faster. So this is just an overview of the actual results performed by the two different 20-ton systems, CPT systems, one with and one without the innovation friction reducer. You'll see on the left the deeper penetrations close to 60 meters. Towards the right side of the slide, you'll see the measured thrust and frictions being higher for the non-friction reducer system. So the Blue Dragon is an innovative C4 drill that is going to come up in the market soon. It is designed purely from our experiences over the years. I'm sure the other suppliers as well are also building up based on the experiences. So we put HSE as a forefront of all this because we feel that this kind of assets are there in order to reduce the amount of people also that is required on board vessels, or probably handling things or equipment when the operations is ongoing. So the flexibility to deliver the data quality is also very important. So most of the information we get, all the real-time data, it's all beamed back to the beach. Everything that you heard earlier about from sensor to actual getting on the client is available on this in the systems. And reliable technology. I mean, we have robotic deck tooling systems that you don't need to touch the sampling tube, for example. It's all taken out the carousel and then passed on to the laboratory. Blue Shadow is the latest and versatile USV that we have in the fleet. Is performing hydrographic surveys in certain part of this region, and again, it's a proven technology. Now, I don't need to go too much into the details because it's available there in the public domain. The designs were built on scratch. You had a wave pulsing design, for example, to try and carry out surveys quicker and double the output. We see a factor of probably 1.5 to 2 times faster, lower carbon footprint, yeah, and a whole lot of other features and benefits that adds value to the whole survey program. We've reached the concluding section for this whole presentation. With that, I would like to provide some of my insights as a practitioner in this field for some time and my perspective of the future when it comes to geodata and marine site characterization activities. I will also end the presentation with some key takeaways and some key insights, and hopefully it resonates with most of you in the audience. In the future, I mean, most of this information that you see on the screen now is already the present. I mean, there's a lot more that the industry will be coming up with in terms of a lot of fully autonomous vessels and equipment that will actually create a lot more value in any industry. Example, we are probably in the space now. We could say they're probably not in the matured state, but for example, in the semi-autonomous element where there's supervised child and parent vessel type of configuration, we're probably already there in terms of providing solutions to end clients. I mean, we have also implemented a lot of remote kind of operations via, for example, ROVs. I mean, we have electric ROVs now. We have electric LAS systems. We have the latest technology USVs. We have, as I mentioned earlier, in terms of robotic drills. And on top of all those, we have the digitalization process that's happening now. With this digitalization process, and together with the increasing deployment of remote and autonomous systems, I think we need to understand there's a huge shift towards taking people away from the vessel onto the beach. And when you have more people back on shore, there needs to be that skill sets as well that's available. So I think for all the aspiring graduates out there and also existing practitioners, there's a sense of optimism there, because a lot of work is going to remain or even increase, because just the number of work or the requirements in this space is just going to increase over time. So talking specifically on the oil and gas industry here. So as we all know, in most of the countries globally, most of the easy oil and gas reservoirs has probably already been found. So the growth going forward is most likely to search for those locations that might be in remote or in deep water locations. Yeah, and what that means, as we all know, is going to geologically can probably get more complex. So that involves a lot of expert suppliers and companies to actually add and create value for the risk owners. Now, as we look from this report from Rystad, in terms of the offshore oil and gas market spend for the next 2 to 3 years, you would see a healthy 7% increase. Now, we all know that if the pandemic did not hit us last year, this would have been actually fast forwarded by at least 2 years, and we probably will be on the higher growth curve at the moment. But with that perfect storm that have happened to us in the last few years, I think the positive side of all this is to actually understand that most of the companies have evolved, have adapted, have actually spent money on the R&D space, and understood that when the market actually comes back and the demand comes back, we want to be in a position to launch forward and show that value to the end clients. So I can easily say this, that we're probably in a position now to probably do the same amount of work twice as fast now, and probably even scale up even faster depending on the assets that each company has, and create that kind of value. So the return on incremental investment for the end client is actually will be proven to be actually much less for the end client. So there's a lot of positives that's come up from all this, the the perfect storm that's happened in the industry for the last so many years. So yeah, so I mean, there is in this graph they shows a modest growth in the shallow water and more in the deep water, but I think it's going to be a kind of a scenario where it's going to be a pretty even playing field going forward. Now, specifically talking about the renewables industry, especially offshore wind, I think there's been a lot of optimism in this industry, in this region, for the last 5 years or so. I mean, that is being led by Taiwan, for example. But as you see, the growth potential is actually huge. It's not just Taiwan anymore. There's Japan, there's Korea, there's Vietnam. There's many more countries in the Asia Pacific region. So the growth rate that's being expected is actually a huge 24% here. Yeah. And with this, the focus is on the supply chain as well. I mean, how many companies can actually support the development of offshore wind farms in the region? Now, with the introduction of the floating wind farm concept as well, it shows that there's a lot of suppliers that are willing to actually invest in the region, and as a result, there'll be a lot of growth in terms of whether it's wind turbines, whether it's generators, cables, and even suppliers like ourselves that are in the MSE space that provide data acquisition services. So yeah, the other service offerings that I did not mention earlier in the innovation is what is already there is boulder mapping algorithms, especially in the offshore wind. That's very important because it's very close to shore, is to understanding the geology as it gets closer to land. So boulder mapping algorithms is already there, and we have ourselves as well as other service providers have actually proven the value. Route optimization, again, this is more to innovative least cost routing of cable techniques, yeah, allowing installation constraints to be incorporated in the primary algorithms rather than considered in post-processing. And finally is the cable burial assessments. So there's predictive models now that can provide reliable burial assessments and back analysis of trenching tool performance along the cable routes. Another industry that is still thriving and is still very progressive is in the scientific deep water area, where deep sea mining and gas hydrates forms a major part of it. Now, for deep sea mining, companies like Deep Green has been in the forefront of gathering information of areas where polymetallic nodules or manganese nodules can be found. As an example that I've provided, and you see the pictures on the right, it's an expedition that we did a year ago off the coast of America, about 1,500 nautical miles away, where we had to do a combination of deep water AUV surveys and geotechnical and mineral sampling. So what you see there on that's being assessed and identified by the geoscientists there are actual manganese nodules. They believe, rather Deep Green also believes that this site that we investigated is probably potential for at least 140 million electric cars of the future. So for gas hydrates, the other industry, for example, it has been there for the last 10 to 20 years anyways. Japan, China, and Korea has been the forefront. Yeah? India and USA have also been active in these areas. Now, the goal of these expeditions have always been to gauge the magnitude of such energy sources available in deep waters with the aim to get into production mode if the reservoirs are significant. Now, to conclude, the key takeaway that I would like to highlight to the audience here is it's critical that we focus on the AAA approach of acquisition, analysis, and advice because it helps all project stakeholders to make informed decisions and also to de-risk the location from all the way from the concept stage to the completion phase. Yeah. So for that, I would probably say there are probably 5 key finer print points here, in the sense that I think it's important for all of you to take back, and I hope it resonates with some of you as well. Number 1 is minimizing risk and maximizing value creation. We need to look at MSA activities as an investment with a high value multiplier effect and not just as a cost item. 3 is technological innovations and geodata workflow digitalization needs to be in the forefront of all MSA activities. Number 4 is it is not a zero-sum game. I think most of the companies now have already adapted and are agile enough to show the value to the end clients. And number 5 is basically what I would like to end the presentation with, what the statement by the Greek philosopher Heraclitus, in the sense of change is the only constant, and agility to adapt is actually vital to the success of the industry in general. So with that, I would like to end the presentation here. It was a pleasure of mine to actually provide this information to all of you. I'm more than happy to actually take any questions outside of this. In view of time, I've taken a bit longer than I should. However, hopefully as of your interest, I'm more than happy to take any questions outside of the conference as well. My contact details are here, or please contact the organizer, and they'll find ways to actually get you connected to myself. Thank you very much, and have a good day.